sir, you are not a teacher, but you are a teacher of teachers. You have taught
No, no,
many
no.
of us in
I
many different areas.
my ideal is Dr. A.M. Deshmukh. My ideal is Dr. Ajay Kumar Srivastava. So wonderful to be a teacher because teachers build a nation. We ruin nations. Honestly speaking, we ruin it and you build it. There is a difference.
And you, sir, Uma Shankar sir, you have become a household name for my students. And
Thank you.
Correct.
That's your kind gesture. Thank you.
yeah.
Very good, very good. So,
In this semester also they have to study environmental science, and I'm putting two lectures for you to deliver.
Oh, thank you, sir. I will. Sonjit Singh ji, are you from Punjab?
I'm from Chandigarh.
Chandigarh. Lovely.
Chandigarh,
It is a wonderful city. Wonderful and well-planned city. I've
Yeah,
been to
it's a
Chandigarh
beautiful
while on a All India tour. I mean, when we are subjected to Masuri Academy for the 4 months foundation course, then sent to
Chandigarh is
different.
known as the city beautiful.
Yes,
City beautiful.
most beautiful city, most planned city.
so Dr. Ajay,
So
about 40 members have joined.
yeah, this is a very 48 members.
48.
48. So, yeah, 48.
8 plus 40. So this is a very big number, very decent number.
Yeah. So you can proceed now.
Yeah. Yeah. Welcome, ladies and gentlemen, to this forum. And despite the fact that we have gone offline since April 1st, but the test we got with the online system, this is going to stay. Just like after Dal Bhat, if you have tested pizza, uh, even if Dal Bhat comes back, you will never miss the taste of pizza. So, kind of that. And this time, for a change, we have introduced the biotechnology students to do the organizing thing. Previously, only botany students used to do. Students of my department used to do. But these students, they have gelled together very well, and they have taken whatever needed. They did not hesitate. Sir, ऐसे होगा, वैसे होगा. They never hesitate to ask anything whenever they were in a sticky situation. So hats off to these students. And may I request Ms. Sharanya to take over from here.
Thank you so much, sir. Good evening to all the respected delegates, professors, and fellow students present over here. Myself, Sharanya Karmakar, Secretary of Student Unit MSI, would like to commence with today's national webinar, conducted by the Microbiology Society of India Unit of St. Xavier's College, Ranchi, on World Malaria Day. Thanking our respected principals, sir, Dr. Father Naboris Lakra, Dr. Ajay Kumar Srivastava, HOD, Department of Botany, St. Xavier's College, Ranchi. We begin with today's program with a prayer by Soumya Bachu. Soumya.
Thank you, Sharanya. Let us close our eyes and remember God. Dear Heavenly Father, we thank you for this wonderful evening. We also thank you for keeping us safe and healthy. Bless all the speakers with your wisdom so that they can convey their knowledge with us nicely, and also bless us, the listeners, so that we can acquire the knowledge which will be shared with us. We also ask for your grace and blessing so that this webinar will be a fruitful evening to everyone. With this, we thank you, Lord. Amen.
Thank you, Soumya. Now, I would like to call upon our respected chief guest, Dr. Swaranjit Singh. Recognized among 2% global scientists, Dr. Swaranjit Singh has contributed versatile fields, including environmental biotechnology, ecology, bio-nanotechnology, and biosurfactant production. On an interesting note, he got the title of the Singing Scientist, having over 32 years of excellence in administrative management, liaison skills, and R&D experiences as a senior principal scientist and head. He was inducted scientist as a member of the Bhopal Action Plan in and around UCIL last year from CSIR, and also an editor of the Science College magazine. Being a member of WFCC Talks Group, he has led person in the brainstorming session in BPU, member of NBA Chennai, task force in diversity, and He has guided 8 PhD students and currently supervising 3 students in their PhD. He has been awarded with Loyola Award, Chennai 2011 and Bharat Jyoti 2011. His group has made excellent contributions in the research on hydrocarbons and enzymes, fermentations and biosynthesis. In the course, they have reported 3 novel bacterial taxa. Dr. Swaranjit Singh has many papers in the IPR field in reputed journals like PBRC, WFCC, Newsletter, CSIR News, and Views, and writes popular science articles, having over 142 publications in high-impact journals and has 32 book chapters. He has edited a book, Nano Biomedicine Study. He is editor, reviewer of many international journals. So please, the mic is all yours now.
Thank you, Saranya, for the nice introduction. I'm to the MSI and St. Xavier's College, Ranchi, for the opportunity to talk to all of you today. I'm thankful to Dr. A.M. Deshmukh for suggesting my name to speak shortly for this meeting. So now I'll on the PPT. I'll share the PPTs with you. Can you see the PPT? Can you see the PPTs?
Yes.
Yes, sir.
Very good.
Yes, sir. Yes, sir.
Okay. Today we have 3 resource persons to talk on malaria. They will talk in details about what is malaria, what is the treatment of malaria, etc. I'll give you a short speech on how to eradicate malaria. There's a big question mark on this. How can we eradicate malaria? It's a tough job. People are working for many, many years to get rid of malaria. I'm sure one day we will not have malaria on this planet. Let me introduce you about malaria. I will take an early ways to fight growing mosquito resistance to pesticides and malaria parasite to anti-malarial drugs. These are the mosquito control measures. The first one is environmental control, chemical control, and biological control. I would like to say one line about biological control. The larvae can be controlled by a bacteria, mostly Bacillus thuringiensis. Bacillus strain spores can kill the larvae. If you spray insecticide in the drains, in stagnant water, most of the larvae are killed. Some people use fishes. There's a mosquito fish which can feed on larvae and finish the larvae effectively. Then, number 2, there is space sprays, residual sprays, genetic control. I'll come to details of genetic control later. The third one is use of mosquito nets. They are specialized nets, not simple mosquito nets, which I will talk to you later. Then there is screening, and the use of repellents. Then there is legislative control, the civic laws. The states have orders not to have stagnant water, not to have water in the pots, flower pots, etc. Now let us read of this interesting insecticide-treated bed nets. Insecticide-treated bed nets, also known as ITNS, reduce malaria illness, severe disease and death due to malaria. ITNS have reduced the death of children under 5 years by about 20%. The children are more prone to mosquito and the larvae. The bed treated with an insecticide is much more safe and protective.
Excuse me,
Only
sir. Sorry
two
to interrupt you.
insecticide classes are approved for use
Sir,
on
excuse me.
ITNs.
Excuse me, sir. Sorry to interrupt you. Sir,
Yeah.
your desktop is visible, but your slide is not visible. I think for others also, only desktop is visible.
Yes, sir.
Can you minimize your
Yeah, I'll
window?
minimize.
Yes, sir.
Minimize. Is it all right now?
Yes, sir. This is okay now.
Is it? It is okay now.
Yes, sir.
All right, very good. So the bed treated with an insecticide is much more protective. There are two insecticides that are in use, pyrols. These insecticides have a very low health risk to humans and other mammals, but are toxic to insects and kill them. Long-lasting insecticide-treated nets, LLINS, that maintain effective levels of insecticide for at least 3 years, even after repeated washings. It is estimated that up to $3.8 billion could be saved worldwide over 10 years by increasing the lifespan of mosquito nets from 3 years to 5 years. This is a child sitting in a treated bed net with insecticide. He is much safe. He is very safe in this treated bed net. As I told you, the children are more prone to malaria. But if they sit inside the nets, sleep inside the nets, the mortality falls down drastically. Now let us talk about genetic control of mosquito. Gene drives for mosquito population replacement are promising tools for malaria control. There are mosquitoes known as flightless mosquitoes. No flight, no bite. If the mosquito cannot fly, the fellow cannot bite. By editing Act 4, female mosquitoes were unable to produce functional actin protein, resulting in defective flight muscles. They were incapable of flying, while the male counterparts could fly since they use a different gene for their actin. The males are not dangerous, only the female mosquitoes are dangerous. The discovery of flightless mosquitoes, no fight, no bite, has great potential for future use in genetic population control methods. People are using mosquito hives, small hives of mosquito, where mass genetic transfer occurs. And then the whole population of mosquitoes lose the ability to fly, the females. This is a very interesting discovery. As we just discussed, loss of ACT4 in females leads to disrupted muscle fibers in flight muscles. Hence, they cannot fly, they cannot spread malaria. If we can do this worldwide by the assistance of WHO and other bodies, we can achieve this target very soon. Some people say we can get rid of mosquitoes by 2027. Some say we can get rid of mosquitoes 2030. Some people say we can get rid of mosquitoes in 2040, and the others say 2050. But I'm sure the day will come when our planet will not have mosquitoes. It will disappear like polio. Now, another interesting way to kill the mosquitoes is nanotechnology. Nanotechnology plays a major role in fighting malaria. Palladium, PD, platinum, PT, zinc, Zn, and silver, Ag, are metallic nanoparticles that have the potential to control malaria population existing in the environment. Zinc oxide nanoparticles have extensive applications. They have larvicidal and anti-plasmodial activity. The non-toxic and low-cost production properties makes these nanoparticles very useful in malaria prevention. Most suitable solvent for zinc oxide nanoparticles is distilled water and deionized water. Efforts are being carried out to utilize these nanoparticles by spraying on plasmodium surfaces after solubilizing in dilute acid and dilute bases. I am very fond of the magic molecules known as biosurfactants. My group did extensive work on biosurfactants. These are actually surfactants which are having surface active properties. These magic molecules or wonder molecules have a lot of applications. They can solubilize pesticides and insecticides used in sprays to kill the pests. They can solubilize nanoparticles and metals so that the spray is homogeneous. As we discussed, nanomaterials in the fight against malaria. Nanomaterials, that is nanoparticles, can effectively deliver anti-malarial drugs to kill the parasites and avoid drug resistance. They also prevent toxic side effects to the humans and to the other mammals. This is what I was just talking to you about, the surfactants and biosurfactants. If you mix surfactant or biosurfactant to the insecticide spray, it can penetrate the pest and the leaves in agriculture, the weed leaves in agriculture very effectively. It forms a homogeneous spray of the insecticide or the larvicide, and also of the nanoparticles, which happens in combination with surfactants and biosurfactants. This is the Global Malaria Eradication Program, which was established in 1955 to eradicate malaria. Bill and Melinda Gates Foundation proposing a plan to end malaria by 2040. The recent developments in boosting the malaria eradication program is the development of vaccines. Malaria vaccines have been in development since 1960s, with substantial progress in the last 10 years. October 6, 2021 marks a historic day in the development of malaria vaccines with release by WHO. RTS-AS01 vaccine became the first malaria vaccine to receive a WHO recommendation for widespread use. More than a dozen vaccine candidates are now in clinical development. Take care and practice the prevention methods that you can easily do. Cover the exposed skin. Use herbal repellents and drive the mosquitoes away. Thank you.
Thank you, sir. It was really very informative. Now, I would like to call upon our chairperson, Dr. Uma Shankar Singh. Sir, for a period of 3 decades serving in the Indian Forest Services, Dr. Uma Shankar Singh has been certified in the course of Environmental Impact Assessment from Bradford University, England. After completing his PhD from carbon sequestration in salt forest, he also finished his BSc from carbon sequestration in different species of plantation forests in UP, publishing not only more than 20 research papers in various national and international journals of review, but also many articles in magazines. Being an expert in forestry, wildlife, climate change, worked as a director Planning Commission of India. Along with it, he had also served as the director of the Daudha National Park. Currently, 8 students are working as PhD under his guidance in Ranchi University. He is honored with Mathur's Gold Medal at Indian Forest College, Delhi, Director's Medal at Lal Bahadur Shastri, Nainital, Academy of Administration, Mussoorie, Governor's Medal for creating high-tech nursery, Kalika Prasad Award in the field of excellence in social services like Eminence Awards. Apart from this, he has been member secretary of many governmental, national and international commissions for forestry, wildlife and environment. So please, we are all ears to listen to you. Excuse me, sir. Sir, your mic is not on.
Yes, now are you hearing me, Saranya?
Yes, sir.
Yes, thank you. Good evening, everyone. And I don't know how to say my, how to show my gratitude towards Ajay ji and others that have been given a chance to interact with you on this issue. I will like to be a listener today because there are many experts who are just going to talk on the issue, and it's extremely relevant, the malaria. Having done my MSc and then got into forest service, I decided to go in for carbon sequestration and now trying to understand and learn climate change. So that's a small part of my journey. The other day when I was in Kanpur IIT for a small lecture, and the gentleman who was speaking before me was saying that he had done a very simple research, and the research is simply simple. Otherwise, that once it is complicated, probably we are not able to understand them. So he was trying to understand the rise of temperature in some of the cities in and around Kanpur. So he chose 9 districts around Kanpur and studied the temperature rise. The IPCC says that the temperature is somewhere around 1.2 degrees Celsius. That's the rise. But when he was presenting his paper, it said that the temperature has gone beyond 1.8 or 9 degrees Celsius in and around Kanpur. Lucknow is also one of them. So I was really surprised because the temperature has gone up and the If you look at the carbon dioxide, the presence of carbon dioxide in the atmosphere, it has also gone up by 413 ppm or even more than 413 ppm. The other day when I was in Kolkata, I was working with one of the students on a sea level rise, and some of the islands have already gone inside water. The notably one is the Ghoramara Island, on which I'm working with him. He's my student, and we are working on the climate modeling when this is going to be entirely inside water. So it's a matter of chance, it's a matter of time only when we'll see that island sunken fully. The entire island was somewhere around 26.7 square kilometer. Today we are left only with a 6.7 square kilometer. And the two smaller villages of the Ghoramara Island has already gone inside water. So that's a small thing. When I went there and tried to talk to some of the villagers, the one illness besides cancer that surfaced in a major way was malaria. And I understand the entire island was absolutely cut off from the rest of the world. There is no electricity since we are almost more than 70 years of our independence. But no electricity. The government of West Bengal has never ever tried to install electricity into that village. So I do not understand how the villages are living. They are living below poverty line, and the population is somewhere around 5,000. Still, that's a cause, and that's what I understand. That in time to come, we are going to have the bigger climate refugees in our country in terms of many islands. The other island which attracted my interest was Sagar Island. So these are the issues which really are of great concern for climate change. There was a report published by Ministry of Earth Sciences, the assessment of climate change in India, and it says that if the way this is going, if this goes like this, the temperature of Himalayas would be somewhere around 5 degrees Celsius by the turn of the century. Because having worked in Himalayas for a very long time and intensively, I understand this is on the very, very conservative side. The temperature has already gone beyond 1.5 degrees Celsius in Himalayas, particularly in Nainital. And the place where I was in, and the place where I worked for 3 years, we hadn't had any fan or AC. And nowadays, in place like Nainital, the hotels, the houses have installed ACs and fans. So this is the kind of concern we should have for climate change. And climate change, my dear friends, must understand that climate change is going to impact on the health of the citizens of the fellow countrymen. There are many imjas and moraine placed on the Himalayas. If we go by the recent data, then probably we have 485 imjas or the glacial lakes placed on the Himalayas. And nobody would have forgotten what happened in 2013 when Chorabari Lake was washed away everything. 80% of the road network was washed away in Uttarakhand. That was the kind of magnitude we have had. More than 5,000 people were just washed away. They died. We haven't had any kind of trace of them. So I don't know. Even the government doesn't come out and say that they are dead. But presumably that they are washed away and they are no more with us. 240 villages were almost washed away. They ceased to be on the map of the India. So these are the issues which are involved into the climate change. And climate change is going to impact our life in a way that we would have never seen before. Chorabari Lake happened in 2013. And what really happened? Normally, monsoon comes in the month of July. When I was a small kid and studying in Ranchi used to have frequent rains. But nowadays, Ranchi is also lacking rains. When I joined UP, Uttar Pradesh, as a forest officer, by the end of June, the monsoon used to come. But now it is coming by the end of July. So there is a gap of 1 month. So there is a delay of 1 month in monsoon arrival. But what happened in 2013? The monsoon arrived early. It arrived on 5th, if I recall correctly, if it arrived on 12th or 13th of June in the northern part of the country. Normally what happens is westerlies goes away to the high latitude. But westerlies was also very active. It came down to the latitude where the monsoon was active. And ultimately this brought havoc, devastated the entire thing. Ultimately what happened? Many of us died. This was again repeated. Once, yes, before I move forward, recently I had been to Dehradun in one of my official work. I met one of the gentlemen who was working in Body Institute of Himalayan Geology. He was saying, Bhai Sahab, Chorabari has again filled to the brink, and still the government is not able to pay attention towards those things which are very, very important. 13 out of the 487 glacial lakes are critically endangered. Are very critical for the entire humanity to be eliminated if again that bursts. So that's the situation, that's the kind of situation we have in Uttarakhand. What happened in Rishi Ganga way back in February, in the month of February, what happened? In 2002, the entire Rishi Ganga valley was flooded and it washed away so many things, so many hydro projects. Again, the roads were washed away, villages were washed away. I couldn't tell you that how many of us died there. If go by the government record, probably 257 people died in that Rishi Ganga. So that's the kind of climate change we are having, and nobody understands, nobody says anything. There was a study done and published way back in 2019, and that was published in a journal called Science. And the journal says, the report says that the glacier melting has gone by 2 times in the period of 2010 onward. So let us understand that we are really sitting on the brink of almost elimination. The ISRO says that 70% of the glaciers have already melted, and those glaciers are just going to devastate the entire area. Despite those things, we are not able to understand how to do and how to go about it. There was a gentleman called Ravi Chopra. I met him. The Supreme Court nominated him as one of the committee chairmen to look after or to see into the thing that really we should go in for the hydro projects in Himalayas or not. He recommended that let us stop it here. When the entire world is moving towards the smaller dams, why should we go in for the bigger dams in Himalayas? The Supreme Court accepted the recommendation, and Supreme Court said that, okay, stop it here. Let us not go in for any kind of hydro dams. But yet, we have 43 dams still under construction at different stages. There are 13 districts in Uttarakhand. And out of 13 districts, 7 districts have shown decline in forest cover. In last 30 years, 50,000 hectares of forest land has been given away for the developmental activities without understanding what will this do, how will this play with the nature, how will this play with the environment. So these are the issues, my dear friends. Still we have got 17 major hydro projects being built in the Himalayas without, I mean, with a Supreme Court coming heavy on them. But despite that, they are making it. There was a report, there was a paper published by a group of scientists in BHU. They have come out with a wonderful findings. Nowadays, the World Bank has already earmarked 4 states as the hotspots for the climate change. Madhya Pradesh is one of them. Uttar Pradesh is also, Maharashtra is also one of them. But this group of scientists, they have come out with a finding that an increase in 0.5 degrees Celsius of temperature, the mortality rate would be enhanced to, would be somewhere around 2.5%. If the temperature increases, the mortality rate would go up to 32%. And if the heat wave continues for a little longer time, what may happen? The mortality rate would be somewhere around 78%. And the report says also one thing which is not being noticed by many of us. The center for the heat waves, which normally the northern part of the country used to have the heat wave centers, the hotspots. Now they're shifting to those areas who are not known for it, like Karnataka, like Bangalore, like Hyderabad. So the southern part of the country is also going to have those hotspots for the heat waves. So, my dear friends, these are the issues which are to be tackled, because this is not only one thing. This is just going to give you something in health sector also. And malaria is also one of them. When I had gone to Kolkata for Goramara inspection, I saw that the cab drivers, they refused to fly in between 10 o'clock and 4 o'clock because the temperature is so high. The heat is unbearable. So I would like to end here, because I would like to listen to others. And the climate change is also related with many issues. Malaria is also one of them. And I was just going through one of the papers which says that malaria is going to appear in those areas which were not known for malaria in past. Like if you go to Nainital, you go to Mussoorie, you will not find any mosquito, you will not find any flies. But now you go there, you will find them in plenty. So these are the issues which are of great concern to me as a learner in the field of climate change. So thank you, Saranya, for having given me an opportunity to speak to all of you. And I would like to listen to the learned speaker on malaria and how to contain it, because this one platform where learning is more than speaking. Thank you. Thank you. Charanya, are you hearing me?
Yeah, Umar sir, that was a wonderful sojourn through this event. Sir, you will have one more thing to do. You will have to announce the names of prize winners of one competition they had organized 3 days ago. The volunteers will connect to you.
I will.
Thank you. Thank you,
I
sir.
will. Thank you. Welcome.
Thank you, sir, for such a wonderful talk. A very warm good evening and a heartily welcome to all. Myself, Riya Gupta, President of MSI, Jharkhand Student Unit. I am honored to have Dr. Dheeraj Kumar Nanda as our first resource person. He is an assistant professor, School of Biological Sciences at Asian Institute of Public Health University, Bhubaneswar, Odisha. He worked as a research associate at ICAR National Dairy Research Institute, Karnal, worked as a senior research fellow at ICAR National Bureau of Animal Genetic Resources, also worked as junior research fellow, worked as lecturers at Marwadi College, Ranchi, and as a guest faculty at Birsa Institute of Technology, Ranchi. He was awarded with the Senior Scientist Award by MSI during session 2020 to 21, Best Teacher Award for Odisha State by MSI during session 2019 to 20, Best Poster Award at Pune in 2012. He completed PhD in Biotechnology in 2016, then MSc in Biotechnology, PG in Diploma in Intellectual Property Rights, also done PG in Diploma in Clinical Biochemistry and Medical Biotechnology, qualified ASRB NET conducted by ICAR in 2015. I cordially invite Dr. Dheeraj Kumar sir to speak. Now the mic is all yours, sir.
Thank you. Thank you, Ria, for introducing me. So I also belong to Ranchi, so it is my hometown. So I'm very much happy to have a lecture at St. Xavier's College, and I am honored to be there. So my talk is related with the anti-malarial drug and its uses. Is it audible?
Yes, sir, you are audible.
Yes, sir.
Yeah. So first of all, the theme of this year in the World Malaria Day is harness innovation to reduce the malaria disease burden and save lives. So this malaria, if we see the world scenario, so we see that most of the prevalence of this malaria is due to the transmission of the disease via the vector, and here the vector is a mosquito, that is female Anopheles. So most of we already know it because we from the starting from the schools we have been taught that malaria is being spreaded through Anopheles mosquito, and half of the population who are infected, they are due to the effect that this malaria or the mosquito which is causing this malaria, they grow in some places mostly where there is some stagnant water, and to control this, most of the best way is that you do not allow any water to log where the mosquito can grow. The other type of intervention can also be taken to control this. If we see the world scenario, so according to the report of WHO, World Malaria Report 2021, so it says that estimated 241 million malaria cases have been seen worldwide, and out of that, more than 6 lakhs malaria deaths have occurred, and this represents around increase in 69,000 more deaths in comparison to the previous years. And in 2021 the number was increased because of the pandemic also, because due to pandemic the health worker could not concentrate on these diseases like malaria and other diseases. They were more concerned on the COVID. So due to that, in this 2020 to 2021, it has been seen that the malaria rate increased in comparison to that of the previous years. But besides this, it was a good news that two of the country like China and El Salvador, they have been declared malaria free, and it has been told that around 2025, more 25 countries will be cured or they will not develop this malaria, and this is because of these interventions which are being taken to cure the malaria. Now worldwide, if we see, the cases have decreased due to the interventions which has been taken, and as the previously also sir had told about the insecticide treated bed nest, so they have controlled a lot. Besides that, there is a therapy where the Artemisinin based combination therapy used. So this is a first line of treatment which is being used for malaria, and it has controlled a lot. So I will be talking about this artemisinin based combination therapy only, because this is a current therapy which is being used for controlling malaria. So what is this artemisinin? So this artemisinin is produced by the trichome in the Artemisia annua, which is a plant, and from the leaf trichomes, from the epidermal outgrowth of this plant, this drug is being extracted, and the drug is usually extracted in very less concentration. It is only less than 1% of the dry mass of the plant. And for this artemisinin, the Nobel Prize was given to Dr. Tu Yoyo, who worked, and she gave a new discovery which is confirmed to be a novel therapy for the malaria, and for this she was being given the Nobel Prize in 2015. She is from China. If we see this artemisinin, there are certain other derivatives of this artemisinin which have been chemically converted into artemether, arteether, artesunate, arteninate. So these are some of the derivatives of artemisinin, and the mechanism of artemisinin, if we see, there are two main mechanisms, where one of the mechanism is involving the heme group, that is the iron, and the other is independent of iron. So what it does, that if we see this iron within the food vacuoles of the parasite, it is catalyzed by the cleavage of a peroxidase bridge, forming highly reactive radicals, and these highly reactive chemicals, they modify or inhibit the parasite's molecules. Parasite will be dead. Alternatively, the other process which is there in the artemisinin, it is the use of the ATPase. Here the this parasite, it uses the calcium ATPase system, and here the calcium pump is being prevented by this drug. So as a result, what happens, the this parasite is not allowed to grow and it dies. So in the therapy, there is a combination of this artemisinin is being used, which is in companion with other drugs like lucifermentine is there, and mefloquine is there, amodixine is there, which is the companion drugs which are included. Then there are some artemisinin derivatives in which the dihydroartemisinin is there, artesunate and artemether is there. So these all drugs are the combination therapies which are called as the artemisinin based combination therapy, or ACT. So here this artemisinin is a type of chloroquine based, because if you see, most of the countries, they have developed resistance against chloroquine. Due to this, the chloroquine is not being sensitive for use in malaria therapy. And as a result, in 2006, WHO changed the guideline, and they recommended some first-line treatment for severe cases of malaria. And in this, the chloroquine or the quinine-based therapy was being substituted by this artemisinin. And now subsequently, these ACTs are recommended for the treatment for the complications which is due to the falciparum malaria. But if you see, this Plasmodium vivax is still sensitive to chloroquine. So the chloroquine can be used for Plasmodium vivax, but for this falciparum, this artemisinin therapy or the ACTs is there. So here there is a disadvantage that this artemisinin is used as a monotherapy, and it is highly reproducible, because the rate of this recovery is around 10%, and it reads a type of course. So there is 7 days course, and due to this there is some type of problem which can arise. And to just combat this problem, the combination therapy is being used, where the anti-malarial drugs, they are used along with the artemisinin. So this is called as the artemisinin combination therapy, or the ACT. So the duration of this ACT, what happens, that normally it was 7 days for the artemisinin, by is reduced, and after the 3 days also the parasites is being controlled. So the WHO has recommended several artemisinin combination therapies in which this artemether plus lumefantrine, then artesunate plus amodixine, then artesunate plus mefloquine, artesunate plus sulfaloxine. These all are the therapies which are used and are recommended by WHO. So as we have seen that for the chloroquine, the parasite has developed resistance. In the same way, the resistance can also be arise due to this artemisinin. So in the artemisinin resistance, it refers to a delay in the clearance of the malarial parasites from the bloodstream. So when the treatment is given, that time, if there is a delay in the clearance, then it is considered that this resistance can be there. So this is due to some type of mutation which takes place in the parasite, and due to these mutations, they develop this resistance. So to combat this type of resistance, currently the combination therapy which is used, it is fully cured, and it provides a pattern drug with highly effectiveness in the entire geographical area. So in different areas where the resistance was seen for the artemisinin, if this artemisinin combination therapy is used, it can be controlled. So these gametocidal drugs are there. So these gametocidal drugs, what are they? These are the drugs that are formed to and they control the sexual forms of the parasites in the blood streams, and in that way they can control the parasites. So this chloroquine and the quinine, they are the gametocidal drugs which are active against the Plasmodium vivax and other Plasmodium like this Plasmodium malariae, but they are not effective against the falciparum. So for that, this the gametocytic property of this chloroquine based drugs, they are not effective, and for that this also this artemisinin is effective. Then volatility of the artemisinin supply. So as the requirement of the artemisinin is going up, and as I told that the recovery of this drug is very much less, it is less than 1% of the dry mass. So in that way, some type of alternate is required, and the alternate, as we can, if there is possibility that we can clone this artemisinin into a microbial system, then it can be effective. So for that, a synthetic artemisinin is being cloned in the microbial system. So here what is done, that the artemisinin gene is being taken from the plant and it is inserted into the bacterial system, and after that we can get the recombinant product in form of artemisinin as a recombinant drug. So this discovery was been done by the group of Cancelin, and the Cancelin's team, they involved in the reprogramming of the yeast cells to isoprenoids, and these isoprenoids can further be used for production of the artemisinin. So for this work, this Cancelin groups, they received around 42.5 million grants from Melinda Gates Foundation, and they developed the synthetic biological process which makes the artemisinin. The microbial production of this artemisinin, which was being used by the Cancelin's group, they used around 10 genes of this Artemisia annua plant, and they transferred into the yeast, and they created a type of artificial system like the plant. So in that way, the molecular farming of the artemisinin can be done in the yeast system. And this opened a new way to produce this artemisinin even without using the plant. And in that way, the production or the requirement of this artemisinin has been supplemented. So currently the recombinant artemisinin is commercially available, and there is a French company that is Sanofi. They have optimized the large-scale production of this artemisinin, and the drug is being available in the market. So this WHO, they have announced that the acceptability of these drugs have been announced, and they have been recommended for the manufacture for the drugs. And in that way, the drug is now available. And if we see the malaria is a highly contagious disease, we can say, because this malaria is being spreaded through the mosquito. And if we control the mosquito, one way is that we can control the malaria. So for that, several campaigning has been done by the government agencies at the ground level also. And the insecticidal this mosquito nets, they have been recommended, and they are made available to the people free of cost by the government. Beside that, this drug, they have been also used, and whenever there is some type of symptoms, because within the 24 hours malaria can kill a person. So if there is the symptoms, then the best way is to have the drug, that is either it is chloroquine or it is the artemisinin. So in that way, the drugs are one of the way to control the this malaria. And by this all type of innovations in the therapy, we can reach the goal, that is zero malaria target. And one day the entire world will be free from malaria. So this is a message which is required to be transmitted to all the people, and for that only this malaria day is being celebrated. Thank you. Hello. So with this, I end my presentation, and thank you.
Thank you, sir, for such a great talk.
You're not audible, Anup. You're not audible. I think you're not audible, Anup. Can you please remove your earphone so that we can listen? Dr. Nanda, is he audible to you?
No. Anup, you are not audible.
You're not audible, Anup.
Dr. Ajay, sir, can you listen me?
Yeah.
Sir, next
And,
presentation is from me.
yeah.
So without wasting time, can I start my presentation because there is some technical glitch? No problem. So I hope I should start.
Yeah, Dr. Manish, most welcome. Most welcome.
Thank you. Thank you so much, sir.
Please, the stage is all yours, and we are eager to listen to you.
Yes. Thank you so much, sir. My slide is visible to you?
Yeah, it is.
Okay, so I'm going to start my presentation. Before that, I'm very thankful to St. Xavier's College, MSI, particularly Dr. A.M. Desmukh sir for giving me this opportunity, and I'm very thankful to Dr. Ajay Kumar Srivastava sir, also State President MSI Jharkhand, and I heard your name at several places in MSI, and today I am interacting directly today in this session. Yes, sir. So thankful to you also. I'm very thankful to Chief Guest and Dr. Nanda and other speakers and the chairman, Dr. Uma Shankar Singh sir. So I'm going to start my presentation. This is very simple and a very general presentation without any data. And my presentation is started with the last presentation title that was in the Dr. Nanda slide. And there it was target reaching zero. So I'm going to start from here, from this malaria target reaching zero. So on this World Malaria Day, we can't say about Indian perspective only because around 8 lakhs deaths, more than 8 lakhs or more than 8 lakhs deaths per year in Africa is taking place because of this malaria. And, there are 3 types of countries, like African country, Indian perspective, if we talk about India, and then China. So why I have taken, why I have chosen this topic, because in case of China, consecutive 3 years, there is no incidence of malaria from, I think from 18 to 20, it means 2018, 19 and 20. There is no incidence of malaria that was seen in China. And as compared to Africa, still the cases are very high there. And in India, cases are lowering down. But again, this is going to be uplifted because of this COVID-19 and like sir told, because of the climate change and other things. So here I'm going to start with this malaria target reaching zero. So why this topic I have taken? Because whether we are going to achieve this target of zero or not, this is a challenge for us, for Indians. So I am working at MIT Institute of Biotechnology, MIT University, Madhya Pradesh, as assistant professor, and I'm working as MP State President, MSI also. So I'll take 2-3 slides for a little introduction here. So malaria is caused by a parasite that is passed from one human to another by bite of infected Anopheles mosquitoes. So this is female Anopheles, and the infection, the parasites travel through the bloodstream to the liver, and this is going to be fatal. This is going to be fatal, and there are so many symptoms that is going to be observed, and it is reaching to the bloodstream, and then it is going to infect the RBCs, and the parasites there, it is going to multiply itself and inside the red blood cells, RBCs, which then break open within 48 to 72 hours, infecting more blood cells. Malaria can be carried by mosquitoes in temperate climates, but the parasite disappear over the winters. Mostly the tropic and the subtropic area people, they are going to be infected. In temperate region, this is not very widely distributed, or this is not seen, or this malaria is not going to cause people in those temperate area. So all of you are well aware about this malaria parasite. This is a potentially life-threatening parasite disease caused by different species of Plasmodium vivax, malariae, falciparum, and oval. basically this. And one new novel species is also going to be discovered here nowadays, that is detected, and that is also reported at several places. So it is transmitted by infective bite of Anopheles mosquito, develop disease after 10 to 14 days. So these are the very basic introduction about this malaria parasite. So here in this in this and in my presentation, I am going to take one case study also, so that we can see whether we are going to achieve this target of 0 or not. So infection with this Plasmodium falciparum is the most deadly, and in all over world, this is known that the most dangerous organism we talk about, this is the this parasite that is going to, or you can say this is the malaria, or the malaria causing parasite that is going to be deadly all over the world. So malaria has been a major public health problem in India. There is the intermittent fever, and there is the postulate that intermittent fevers were due to the bad odor coming from marshy areas, and gave the name malaria. Because of this intermittent fever, the name this malaria or the bad air, this is going to be originated. In spite of the fact that today causative organism is known, the name has stuck to this disease. Symptoms already I told you, and in this symptom, there are a number of symptoms that is going to be observed here. Malaria may be simple, or you can say malaria sometimes it is going to be very, very severe also. So parasites are carried by blood to the brain, even that is the part of the cerebral malaria, and to other vital organ also. Malaria in pregnancy poses a substantial risk to mother, the fetus, and newborn infant. The pregnant women are less capable of coping with and clearing malaria infection. So sometimes this is going to be very fatal. Close to 1.3 billion people are at high risk of being infected with malaria in India. India carries 2% of the global malaria case burden and 2% global malaria deaths. 52% of all malaria deaths outside of sub-Saharan Africa. India also bears 85.2% of the malaria burden in Southeast Asia. Why I am giving this data? Because on the basis of this data, we are going to conclude in the last whether we are going to achieve this 0 or not. So of importance is that India carries 47% of global Plasmodium vivax malaria burden, making the country strategically important for global malaria elimination, particularly in Southeast Asian region. And according to WHO report also, India still has one of the highest case loads of malaria in the world. Although in the last couple of years, the country has seen a drop in cases. So it is not like that we are not coping up with this disease, or we are not going to reduce the cases because of different the measures that we are going to take up. But still, this is not eradicated. So for eradication, or you can say for the complete eradication of malaria, the awareness program is very, very important. And through this awareness program, not only in urban area, to rural area, to tribal area, we should take on the day of this malaria day, you can say we should take a place for the improvement of the treatment seeking behavior also. So that's why this is a challenge for us also. And here we are going to discuss something about the geographical distribution in India, because I'm talking about the different cases, different incidences about the malaria. Here I'm going to talk about two types of distributions here. One at means the Indian perspective, and second at global. So two graphs we have here, or two images we have here. You can see the first one and the second one. Just 7 out of 36 states in the country accounted for 90% of the estimated cases in 2018. These states, together with other states in northeastern part of India, have some parts of it being either forest-like, hilly, tribal, or conflict affected, and have historically had a large burden of malaria. So this is the prevalence in India. You can see different states are there, and the color is shown here in this figure. If this is intense color, you can say the cases is very high. Here in this region, you can see like in Kashmir or J and K, you can see in this region the cases are very low. And here to the eastern part also, not very much, but in the middle you can see in the middle part of the country, you can see like Maharashtra, you can see the cases are very high. And here in this other part of country, here the dark color, you can see the cases are beyond, I think this is 2,49,000 malarial cases that we can see here. So in these states where the dark color, you can see here the cases or the malaria prevalence is very, very high. So whatever here shown, this is, this is something related to the presentation or the talk that is given by the chairman, sir, that was discussed about the climate change here. So this may be one of the reasons for the climate change, for the geographical location and the distribution of the prevalence or the incidences of this malaria, that is quite related to this climate change also, that I'll discuss later. And here, if we talk about the incidences at the global level, so the picture is very clear here. In case of India, you can see the color of this. On track for 50 to 75% decrease in cases from 2000 to 2015. So it is not like that we are not going to eradicate, or we are not in the process to eradicate. We are not reaching towards zero. This is the case. You can see there is a reduction from 50 to 75%. The incidences from 2000 to 2015. And other, in case of African countries, you can say the incidences are still high. And here, the very, very important thing is that in case of China, from 2018 to 2020, there was not a single case of malaria. So they reached, and this is also a challenge for us, for Indians. This is a challenge for the scenario, for the geographical location, or you can say the climate change that is affecting, and several factors are there. Because of that, we are able to reduce the cases, incidences, but this is also a challenge that we have to go forward for the complete eradication. Now the facts, if we talk about the facts, despite the need, no effective vaccine. So no effective vaccine is there currently exist. Like, in some cases, Dr. Surjit Singh sir told that there is the application of nanoparticles for eradication of pest, and I think that is superficially that is given, but not for consumption as a drug, because the biocompatibility is very important factor that is there. So whether that drug inbuilt with this nanoparticles or the nanocomposites, if that is prepared, whether that is biocompatible for a human body or not, that is very, very important point. But still we are able to eradicate the pest with using these nanoparticles with these drugs. But to inhale about, or to take in drug in our body, this is challenge whether this is a biocompatible formulation or biocompatible drug or not. So there is no effective vaccine currently exist. All the research is going on. A cheap malaria vaccine purified from milk is of genetically modified mice has protected monkeys against the disease. Only 1 of 5 immunized animals contracted the disease, compared with 6 out of 7 unvaccinated monkeys. So still we are in the process, like Dr. Nanda described there, that we are in the process, and still we are trying, and the people, they are doing the sophisticated research to get the effective vaccine. A large number of compounds are being tested for usefulness as anti-malarial drugs, like Dr. Nanda described there, the use of hydroxychloroquine. In March 2013, an American research team reported ELQ-300 was highly effective at preventing the spread of malaria in preclinical mouse trial. In addition, ELQ-300 did not generate drug-resistant strains of malaria parasite and would be far cheaper to produce than current treatment. So we have challenge for the anti-malarial drugs also, because the resistance is also there, that is going to be enhanced day by day. Like in case of antibiotics, the resistant from the bacteria, the resistance is going to be developed in the similar way the anti-malarial drugs. Whether they are accurately that is working or not, that is also a challenge for us to reach this goal. Now, one case study, the analyzing malaria surveillance data in Darjeeling. I'll tell you only 2-3 slides are there related to this data, analyzing malaria surveillance. So here in this data, in this table, you can see this is the reported cases of malaria by months from 2000 to 2004 in Darjeeling district, West Bengal. So here you can see a month-wise description is given here. What are the different cases from January to December, and the Plasmodium falciparum in 2000, the incidences are given here. This is 101, and as we are going to forward years, here we can see that the number or incidences that is going to be increased. So here this is going to be 2,725 in this time. But you know, this is the one case study that was done here in 2004, but it is not like that we are not going to eradicate, not completely, but we are in the process to eradicate. We are going to minimize the number of cases here by the years nowadays. And like Dr. Nanda also told that because of this situation of COVID-19, this is going to be relapsed again. So here in this graph you can see this graph is between year and annual incidence per 10,000. Here we can see the monthly incidence of malaria in this Darjeeling district block in West Bengal. And here you can see ultimately this is going to be increased till 2003, and now this is going to be minimized. This is going to be eradicated or in the process of eradication by the time. Malaria among selected population groups. The distribution of here, the distribution of incidence of malaria in this region indicated that the southern part of block is more affected. This part of block is located in plain and is characterized by proximity of forest and rivers shown on map. This is also quite related to climate change, you know, that was discussed by the chairman sir and Dr. Uma Shankar Singh sir. So this is also, you know, maybe related to the climate change and the geographical situation, locations and everything that is quite related to this, the prevalence, or you can say the more prevalence of this malaria to the southern part of this block. The average yearly incidence of malaria in sub-centers of this block of Darjeeling is discussed here, that is explained here. The forest region is given here, the river region is given in this different color, and here we can see the incidences here, that is more than 20 in this black region, that is the forest region, and less than 2, or that is about 0 here, just above this southern region of this this part of this Darjeeling. Distribution of malaria by age 6 in this district, West Bengal. Here we can see the age group and sex group is given here, and again here we can see the year wise if evaluation is there for the incidences, that is going to be increased by the time. Here after some time you can see there is the decrease, and but again there is the increase in the incidences. Overall, the epidemiological data indicate that the malaria incidence has been increasing in this region between 2000 to 2004 with a higher incidence during the second part of calendar year. And a number of sub-centers located close to forest and rivers are most affected, and that incidences are high in all sex age group, suggesting unstable transmission and lack of immunity. Overall, it suggests that the change in epidemiology of malaria in this region could be a consequence of climate change. So again, I am going to come up with this climate change region that was discussed by earlier. Now, the measures taken in India that we are going to reduce this number. The country has made significant gain towards malaria control and eradication. In 2019, there were 6.8 million fewer cases than in 2016. So we are reaching towards 0, but not yet. We have to achieve the goal, and the number of cases per 1000 of the at-risk population fell from 10 to 4.3. This is also very good, good data that we are going to achieve in Indian perspective. Over the same period, death also fell from 0.018 to 0.06 per 1000 of the population at risk. Now, in conclusion, because this was very, very basic journal without any, sophisticated data, my presentation was there for the awareness. And it must be started from junior level school kids. Awareness is required, not to urban people. Have to move towards tribes to have a challenge to make it real towards zero target. And challenges are different cadre and different level of people working in the country. The greatest of this lack of robust, predictable and sustained international and domestic financing. This is compounded by difficulty in maintaining, commitment and ensuring regional collaboration at the highest level. The second important challenge is biological, the emergence of parasite resistance that was discussed by Dr. Nanda to anti-malarial medicines, and of mosquito resistance to insecticides. And nanotechnology, it may be one of the solution for this, for the insecticide that is going to be resistant for this mosquito resistance. So there may be some formulation or some thing that is going to be prepared for the eradication of the pest. This double threat has the potential to weaken seriously the effectiveness of malaria responses and to erode the gains recently achieved. In last, I'll just want to tell one thing, that one day I was roaming in my in university at night. I was at inspection. So guards, they were talking to me that, sir, we are doing our duty means whole night, overnight, and we are facing problem with mosquitoes every time. So that is also a challenge. This challenge is at a very basic level. But this challenge for the guards, they are doing their duty at ATMs, they are doing their duties to different institutions, and they are running here and there, they are roaming overnight, and they are supposed standing in at a place in university, and they are facing with the mosquitoes and every time. That is also a challenge for us, and we have to eradicate, and we have to find out some problems, some solutions to eradicate, and for such type of people, those are directly, they are facing this problem. So this is all about my presentation. Thank you very much, everyone, for your presence. Thank you, everyone.
Thank you, sir, for your wonderful speech and presentation. Thank you so much.
Last but not the least, I am honored to invite Dr. Sinos Eskiriachan. He is an assistant professor in Department of Microbiology at Sant Pius X College, Rajapuram, Kerala. He worked at Dayananda Sagar College of Engineering, Bangalore, Karnataka as an associate professor, as an assistant professor, and as a lecturer. He has also worked at Sant Pius X College, Rajapuram, Kerala, India as a lecturer in contract basis, published 10 book chapters in his research and 1 textbook, published conference abstract both national and international. He was awarded with Outstanding Faculty in Biotechnology Award by Venus International Foundation, Young Scientist Young Investigator Award in the same year 2016, Best Research Guide Award in 2014, Best Research Paper Award in 2008 till date, Best Outgoing Student in Undergraduate Level 2003, Best NSS Volunteer of the Year Award 2002. He completed BSc in Microbiology from Kannur University, Kannur, Kerala. He completed MSc Microbiology from Bharatiyar University, Computer in 2005. He completed MSc Bioinformatics from Bharatiyar University, Computer 2008. Then PhD in Biotechnology, Vishweshwarya Technology, Belagavi, Karnataka. So go forward with your talk. Our audience are ready with their ears to listen from you.
Thank you. Am I audible?
Yes, sir.
Okay. Thank you, Riya Gupta, for the wonderful, introduction. Thank you very much for inviting me for this particular program, the national webinar on the World Malarial Day. First of all, I would like to appreciate and congratulate the MSI unit of Jharkhand as well as the St. Xavier's College for organizing this kind of a program. And let me share my screen. Is it visible now?
Yes, sir, it's visible.
Okay, thank you very much. Thanks a lot. Thank you very much, Ria. First of all, thank you very much for inviting me for this particular program, and no, I'm extremely happy to be a part of this particular program. So I know that this is the third talk of the the day, and I will be today is World Malaria Day, 25th April. And another 30 or 40 minutes, I will be dealing with the scope of bioinformatics and computational biology for the and omic science, novel anti-malarial agents. So first of all, you know that malaria, according to, I'm sure that many talk you might have already listened, according to today's the World Health Organization's website. If you go and look, you will be seeing this data. There are malaria, it was a great pandemic, and it was affected in more than 85 countries across the WHO regions. And if you look in 2020, there are 241 billion estimated malaria cases about in 85 malaria pandemic countries, and there were 5% incident in the exclusively between 2019 and 20 due to the disruption on the services due to the COVID-19 pandemic, and the mortality rate is 12%. And if you look for this statistics, exclusively in 2019 and 20, there are 47,000 deaths in 2020 due to the disruption in COVID-19 pandemic. And you know that every 2 minutes, if you look, a child dies of malaria. All children should have the access to life-saving services that can prevent, detect, and threat to the disease. And that is the another important quote of WHO. And you know that if you look the 2022, the World Health Organization, the World Malaria Day, prioritized with a motto of hardness innovation to reduce the malaria disease burden and save lives. And the WHO says that no single approach that is available today will solve the problem. So WHO calling investments and innovation that brings no vector control strategies, diagnostics, anti-malarial medicine, and other tools to speed up the progress of the discovery of novel therapeutic substances against malaria. And this is the quote of the WHO Chief Tedros Adhanom Ghebreyesus. The defeating malaria is absolutely critical to ending poverty, improving the health of millions, and enabling the future generation to reach their full potential. The malaria become a public health nuisance, and it is everybody's responsibility to undertake a good quality research and ending the consequences associated with the malaria, and enabling the future generation to reach out their full potential. And since most of the students have, attending this particular programs are undergraduate students, I thought I will, although you might have heard about the life cycle of malarial parasites. So this is a beautiful paper that is published in International Journal of Anti-Malarial in 2013. In the case of malaria, there is this life cycle you have already studied, the medical microbiology or parasitology. You might have studied this. There is a human phase as well as the mosquito phase in the case of this particular malaria. The transmission of this particular the disease, that is the vector, that the Aedes aegypti, and which inject the sporozoites via the bites, and the sporozoites enter the liver and infect the whole hepatocyte. There will be mitotic replications, and the liver cell will be rupturing, and the merozoites will be released. And this particular merozoites will be undergoing some changes. Especially one important thing is the parasite will be, this particular state, this will be in the ring format, that is the so-called trophozoites, and this is the human cycle. And again, this gametocytes that will be entering, those human that is already infected, that is entered to the mosquito. Those mosquito are biting to the human, and it will be going to the gametocytes will be going to the males. Then it undergoes meiosis, then to migrate to the mid-gut walls from the oocyte, and sporocyte develops, and so-called the transmission will be happening. Actually, from here it will be the vector to the mosquito to the human, and from human to the mosquito, and these particular things are happening. And that the major activities of anti-malarial although we are having this, malaria is become a potential problem. So we are having beautiful, wonderful drugs actually. And, the drug will be, infecting any of the stages, the human liver stages, or the human blood stages, or the mosquito stages. There will be a lot of the intermediate states like sporocytes, or gametocytes, or merozoites, or zizont, all those things. So here you can see there are the drug, the artemisinin, okay, that will be less than IC50 value is less than 1 micrometer level, that will be happening. Then that will be inhibit this sets of drugs. The IC50 value is less than 50. Then the Shison stage. Then you will be having the inhibition at the 10 molar concentration. The 60% of the cases that will be, the gametocytes. Then it will be the 10 micromolar concentration in the case of ookinete or the oocytes. So there are so many drugs are already available to inhibit this parasitic, the intermediates in any of the stages. So that is the another important aspect. Then this case, when that the drug when you will be using, there is a chances of the selective pressure and the all the potential problem in microbiology. Here also the problem is the drug resistance actually. So life cycle will be having a significant relation to the drug resistance, and initially in the human stage there will be low selective pressure, but in the case of this initial case, there will be in the later stage of the human, there will be high selective pressure, and it will be in the case of mosquito, that is the this particular stage, it will be very low selective pressure for this particular case. So here, as I said, there are antifolate that will be specifically targeting this the targets available in the Gisont, and similarly you will be having naphthoquinones, and that also will be targeting this particular specific targets. Similarly, aryl alcohols and 4-aminoquinones and antibiotic like clindamycin, deoxycycline, and endoperoxidase, so such as artemisinin, one of the well-known anti-malarial drug which will be inhibiting this Gisont. So then during all this stage, initially the low selective pressure, later it will be reaching the human stage, there will be high selective pressure that will be reaching. Then there is a this is the way how the life cycle, and that is highly related with the drug resistance. This is a beautiful paper published in Nature Medicine in 2017. And if you look at resistance, the principal anti-malarial resistance and the emergence of resistance is not it's not a new story. It's happened in the very old time in 1910. The first, the resistance has appeared in 1910. Then it's a quinone that become 1910. It become resistant, followed by chloroquine. In the case of chloroquine in between some 1960s, nearly 1960s, that become the resistant. Then people thought about the double doses like Atto nearly 2000. So not only initially there were only single dose, now they become the combination therapies also become the resistant. Then later the so-called well-known drug artemisinins, so artemisinins and derivatives, and nearly 2010 that become resistant. And similarly, you can see so many of the resistant. Now we are we'll be having the combination therapy, the 3 drugs we will be having. So you will be having the sulfodoxypyrimidine, methacmine, and you will be having this artemisinin combination together. But still, that also shows some kind of resistance, and it is reported the resistance in 2010. So that means to say there is a lot of resistance in the existing therapeutic targets and existing therapeutic drug with a lot of problems. So there comes the importance of the discovering of the novel therapeutic target by various approaches actually. So now, as I said in the beginning, that you require initial, there are a lot of interdisciplinary research or such kind of aspects are required to develop novel therapeutic agents actually. And if you look at the same paper, Nature Medicine, if you look what are the molecular mechanisms in which this particular most of the drugs become resistant to anti-malarial resistance to the anti-malarial drugs. So there are 3 targeted pathways. In fact, we have been looking, when you look at the erythrocyte, and these are the 3 important pathways. One is the heme detoxification pathway that is included in the digestive vacuole, and that is, if you look at the digestive vacuole, that will be that you will be able to see there are these are some of the drugs, okay, and this particular drugs like 4-aminoquinoline, or that is such as chloroquine, aminoquine, and pipraquine, all those drugs will be there are that will how it will be become resistant, because there are some kind of point mutation in the respective targets in this particular pathway. So similarly, the folate pyrimidine biosynthesis that is happening in the cytosol, here this you can see the DHFR, well-known enzyme, dihydrofolate reductase. Okay, so here you can see there is a point mutation. Similarly, DHPS also there is a point mutation. So that leads to the discovery, that leads to the the resistance to antifolate sulfonamax and pyridomethamine and cycloguanil, etc. All such kind of drugs shows the the resistance due to this particular point mutation. And another targeted pathway is electron transport system, the inner membrane of mitochondria. Then you will be having there is a potential target, there are some kind of targets, and similar the ribosomes. Okay, so there will be the ribosomal protein, there will be that is the target of this particular drugs like clindamycin and deoxycycline, all those kind of drugs. And here you will be having the ATQ, that is another important drug, so that is atovaquone. Okay, so that is the drug that is specifically bind with the CYTB target in the case of electron transport system of inner membrane of mitochondria. So these are the 3 important target mechanisms. What I want to say is, so there are a lot of mutations and such kind of mutations, relevant type of genetic changes that happened in the genetic level, and that the drug leads to the that resistance. And that is the problem today when you talk about the 2020 25th of April today, when you discuss about the anti-malarial concepts. So the most important concept, the malarial drugs become resistant due to all these particular problems actually. So that there comes my important topic, what is the scope of computational biology and bioinformatics, or the data sciences, for the discovering the novel therapeutic target as well as the lead molecule actually. So before I talk about this one, we have been witnessing the pandemic past 2 years actually. So in the 2019, it was first case, it was reported in our own state, the Kerala. There is a first case is reported, and followed by second, third cases were reported in Kerala, and followed by it was a lockdown. And that the world completely underwent lockdown. Then what has happened? There are all the laboratories in the national level, or the state level, national level, or the laboratory shut down, and researchers, they had to sit in the home, and they had to depend on only the data sciences and computational biology to do this particular study. So that is what I wanted to tell you. So during the time of the pandemic, there are more than 10,000 plus papers they have published in various journals. This exclusively in silico or computational prediction. So they have done with a very, very accurate level. They have done some of the journal, they never accepted any theoretical prediction without any experimental evidence. Okay, such kind of paper also journal also start accepting the papers, and more than several thousands of papers they have published. Now also you can see computational biology and bioinformatics become a very, very important component for the conventional drug discovery sector. So that is why how this drug discovery become getting a boom using this particular area. So why I told this one, just I wanted to highlight what is the role of bioinformatics during the past pandemic, what has happened. So of course, then you know that obviously the same concept will be there in the anti-malarial discovery also. If you talk about the drug discovery process is very, very tough and complicated. It's very, very tough. Okay, so initially, if you start with the 10,000 compound, when you look various screening, the drug screening, initially when you are having a 10,000 compound, just I'm saying as an example, then initially it will become preclinical level. Only 250 will pass out. Actually, only 250 will go in the preclinical level, and it will take, the screening will take a lot of years. The initial assays, the target identification, and all those optimization studies, standardization of the protocol become very, 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 very complex and a tedious task. Approximately it will take several years, and later you will be having the 250 molecule. When it reaches to the clinical level, it will become only 5, then almost 7+ years it will will take, and finally if the company is very, very lucky, finally they will be able to come up with one particular drugs actually. So that is the story of a drug discovery protocol. So in detail, when you look at 10,000 compound, if you go for the testing, then the preclinical level, the lab and the animal experiments, only less than 250 compounds will be going. The remaining all those 9,750 compounds will be eliminated due to various problems or issues associated with the conventional drug discovery. Then the clinical trial, the phase 1, 2 to 20 healthy volunteer, if you check, then later 100 to 500 patients with using the safety dosing, etc. When you check the phase 3, the number you increase, then efficacy and adverse effect, when you check, that out of among this 250, only less than 5 test compounds will be qualified, and that will be reaching to the final level. And the final, it will take the evaluation, it will take nearly 2 years of time, and finally the last stage, only one drug may approve. The company is very, very lucky, and it cost a very, very high investment, initial investment. Here comes the power of computational biology and bioinformatics. What you can do is all the initial part of how can you do with why can't you do with we can depend on the machine learning, the data sciences, the artificial intelligence, and the high level of mathematical modeling or algorithms. So the bioinformatics resources coupled with the biochemistry and molecular biology knowledge, whatever we are having, along with the microbiology knowledge, initially we can depend, and you can speed up the process. I'm not telling computational biology is everything. Finally, it requires the validation by experimental method, and it will substantially save your time and the cost also when you depend on the computational biology aspect. So these are some of the steps. As I told, there is a target identification, the validation of the target, the lead identification, optimization of the lead molecule, and finally the preclinical and clinical studies. Okay, so each and every step you will be having, there are significant role in computational biology in data mining, the genomics, proteomics, 3-dimensional structure prediction of the target, the pathway analysis of the target, knockout or knock-in studies, or high throughput screening. Initially, when you look the drug discovery, you will be having 3. One is based on the 3-dimensional structure of the protein or target. So that is the structure-based approaches. Then the knowledge on the ligand, the small molecule. Then that is ligand-based approaches. Then you will be having the system-based approaches such as network pharmacology, and all these are the computational biology studies, whatever you can do. So the molecular modeling, the 3-dimensional structure prediction, the docking studies, dynamic simulation studies to check the interaction modeling, and later the medicinal chemistry, the quantitative structure activity relationship, the coupled with the chemoinformatics or molecular profiling. All those things you can check, you can do wonderful computational biology studies, and when you do the so-called drug discovery process become very, 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 very easy, and you will be having a model in which that will be having high accuracy, because we are using high-end softwares, the machine learning as well as the artificial intelligence, such a kind of a modern and latest new generation technologies we are going to use to screen such a kind of a drug actually. So when you look at the anti-malarial drug discovery, so this is the everything. As I said, the so-called why I told here, you can see the problem happens here, the resistance that is happening to the target. Okay, the resistance that is happening, the mutation that is happening to the target, so that the resistance, the drug become resistant. So the drug is when the binding site, when it becomes changed, the drug is unable to bind. It will be flipped out of the binding cavity. That is the problem here in the drug resistance. So that is why you should have a novel, target. So you will be having the novel target, the potential target, the malarial parasite. You have to look in one side. You do the the theoretical prediction of the high-end quality model with and their active site prediction and high throughput screening. You can analyze the ligand, and you can do the interaction modeling, and finally, if the interaction is working, you can synthesize those particular components, or it is available in the natural level. You can select and you can do the anti-malarial activity assay against the malarial parasite Plasmodium falciparum. And the other side, if it the target, if it is it is working perfectly, then what you can do, that you will be able to identify the gene. Then you will be able to clone it into a vector and transform into a host, and you replicate that is the replicate this gene in the host. Then you will be able to get the transformers and selection procedure, screening, everything. Finally, you should have the you can isolate that particular protein or target, and you can purify it, and you can do the the experimental validation for further level. So what I'm trying to tell is everything, this computational model, it is very, very important. Initial insight you will be getting through this particular computational models. So now I am talking about this computational modeling. The three-dimensional structure is very, very difficult to elucidate. The three-dimensional method, standard methods like the crystallography, the crystallography. In fact, there is a sad news. The greatest crystallographer in India, Professor M. Vijayan, from Nobel Prize was won to the Joachim Frank and Hendrik Anderson for the discovery, for the development of cryo-electron microscopy, electron cryomicroscopy. In chemistry, they have got the Nobel Prize. And now we will be having a lot of methodology for the three-dimensional structure, of the getting a three-dimensional structure prediction. And the complex, although these methods are available, all these methods will be consuming a lot of time. It's a very, very complex, extremely complex. If you are very lucky, then you will be getting a pure form of the crystal structure of the protein. Then there are people, they work years and years to get the pure crystals or NMR. Okay, a crystal structure, excellent facility. All protein you will not be able to crystallize. Say, for example, membrane proteins, they are highly hydrophobic. So it's very difficult to crystallize. So that is why, even if all this problem you will be having here due to this particular conventional experimental method. But I am not telling that these experimental methods are not good, and everything is computationally dependent only is correct. It's not like that. So it will be helping. You will be able to get a computational biology, you will be able to get excellent prediction. You will be having structural database. When you look structural database, due to the enormous sequencing facilities, next generation sequencing, we are having all those high level sequencing facilities as of today. This is today's statistics. Okay, 25th of April 2022. If you look, more than 24 crores. Okay, more than that sequence are available in the database. But that is not easy for the structure. Here you can see the best structural database, protein data bank. Okay, so that is the protein data bank. This is today's statistics. Only 1,89,735 structures are available. There is a huge gap between the sequence and structure. That is why I told it is very, very difficult to get the experimental approach and come up with a conventional structure. So here comes the importance of bioinformatics in anti-malarial drug discovery. Okay, so when you look there are structures. So there are a lot of experimental structures. Among these 1,89,735 structures, there are today, if you look, 1618 structures are related with the Plasmodium and its different species of Plasmodium. Plasmodium vivax, Plasmodium falciparum. Okay, all those things you can see. These are the majority of the protein structures are available. From Plasmodium falciparum. Okay, there are so many structures. Total there will be 1618 structures will be available actually. But still there are a lot of structures that is not experimentally elucidated that can be used as a probable drug target actually. That is why it is required. Although Plasmodium is a model organism, we are having the complete gene sequence. Okay, the complete gene sequence, the Plasmodium falciparum, the genome has been completely sequenced actually. So each and every, they look the gene sequence properly, and you will be able to get a novel sequences in which the novel gene in which there is no structures are available. So there comes the importance of computational biology. So you will be able to predict the three-dimensional structure based on the amino acid sequence. So from the basic amino acid sequence, so how exactly it is getting folding is happening in the conventional level or in the native form. That the primary sequence, the basic amino acid sequence, can be converted into a high quality folded three-dimensional structure that consisting of the regular secondary structure. And you know that when you look the pathway in the data in the organism, these particular structures can be one of the important targets, okay, among this particular pathway. So then you will be able to study a lot of protein interaction or protein ligand interaction. You will be able to come up with some site of information about this actually. So these are some of the important network. Okay, the pathways you can see. This is the one particular pathway of say for example Plasmodium falciparum, such kind of an organism. There are a lot of important genes. Okay, that particular genes are network connected together. This particular metabolic pathways is some of the important pathway that is the regular functioning of this particular organism, the Plasmodium. So the bioinformatics will identify the three-dimensional structure of this particular target and study the folding pattern of that particular target and come up with a novel lead molecule, and by interaction modeling, so and by prioritizing, by targeting any of the key elements in this particular metabolic pathway, we can inhibit the whole pathway, and will be, that is wonderful anti-malarial drug discovery as aspect actually. So when you talk about this structural prediction, when you look about the three-dimensional structural prediction, there are three important aspects. The very huge area. I'm not going to go for details. Many of you are already knowing. So many of the researchers are already working on this particular area. Homology modeling or comparative modeling. Next one is threading or fold recognition. The third one is the de novo ab initio prediction. So these are the conventional methods for the tertiary structure prediction. The well-known method is homology modeling or comparative modeling. There you'll be having the identification of the target. The target means that the sequence in which there is that is known as the target. Then the template, okay, the template is the experimentally solved structure. That is the template. Then the sequence, there will be there will be a sequence and structural alignment you will be having. Then there will be the building of the model. Okay, there will be the Is it visible now?
Yes, sir.
Is it visible?
Yes, sir.
Okay.
Yes, sir.
I'm extremely sorry. There was some sudden net work issues. So what I'm trying to tell is there are three important approaches for the homology modeling. There are three important methods for the protein structure prediction. One important method is the homology modeling, the best method. So as I said, the target identification, the identifying the target. That doesn't have the three-dimensional structure. The template means you require one reference molecule. In fact, the target, the basic amino acid sequence of the target, so that should have some kind of homologous relationship with the sequence of one of the structure that is already experimentally solved or evaluated. Okay, so that is the template. Minimum 30% identity between the target and the template is required. So that is the another important thing. Then you will be having the sequence and structural alignment. You will be able to align the molecular amino acid sequences. Then the program by seeing the amino acid sequence of the the template. So the program will model the initial model. Then there will be some kind of energy problems or the side chain, the stereochemistry issues for the side chain that can be optimized. There will be the lack of in all the region. There will be some kind of the loops or such kind of a lack of secondary structures that can be built the loop, and finally you can refine the model and evaluate and validate the model by bioinformatics aspect. So this is the whole thing what I have told actually. So here you'll be having the target. This is a basic amino acid sequence. This is the template in which the three-dimensional structures are available. Then this particular target and the structure, that the sequence of this particular structure will be having there is a high amount of similarity. There is an identity, the homologous relationship. Then finally, on the homologous relation, create a model, and that particular model we need to look the energy and several type of assessment you need to look, and finally you need to prove.
Organizers, what's the problem now?
Maybe sir is suffering some network issues.
Is it visible?
Yes, sir.
Yes, sir, it's visible.
Can anyone tell, is it visible?
Yes, sir, it's visible.
Hello, is it visible?
Yes, sir, it is
okay,
visible.
okay,
Yes,
fine,
sir.
fine, yeah. Okay.
Dr. Sinosh, it is visible. Please carry on from here.
Okay, sir. Okay. Fine. Thanks a lot, sir. Thank you very much. So these are some of the important tools that is already available for the high refinement model. So now when you check this particular quality, you can see this is one of the important steps that you need to look when you are checking the quality. So one is cross check, whether you check the stereochemical aspects of the protein. Here, this is the way one Ramchandran plot, that is one of the important aspects, that Ramchandran plot. So this Ramchandran plot, this Ramchandran plot is the perfect Ramchandran plot. So that will be, I mean, that is the Ramchandran plot of a good model. Okay, and this is the Ramchandran plot of a not highly an accurate model. There are most of the residues are the disallowed region of Ramchandran plot. You can see. So these are the allowed regions. When you look, what you need to do is you will be able to. You should look. You should look the Ramchandran plot. So one of the best validation example that you can carry out by the project. Then similarly, ERRAT. So this is another important tool. ERRAT is here it will check the error of the individual amino acid. So this is the plot. Here you can see in the x-axis there will be individual amino acid. You can see the y-axis. You can see the quality factor. So here it is the green peaks are indicating these amino acids are having some of the energy issues that should be validated. That should be refined. Okay, the green that is amino acids are perfectly all right. So you need to get the green peaks maximum to call this particular model is a good quality model. Similarly, whenever you look at the three-dimensional structure, there should be an agreement between the 3D to 1D. Okay, in the one-dimensional to the three-dimensional, there should be an agreement. Okay, so there should be more than 80% of the residue should be having an average 0.2 score. That is then it will be considered as the three-dimensional structure will be having a perfect agreement with this particular proteins. Okay, then similarly you can see the other tool, Gramos, Annular, Cumon, DSSP, all those things. Here you can see the individual amino acids are in the x-axis, and all the tools, the energy level of this particular tools are in the y-axis, and here you can see the green peaks are those amino acids are in the very well stereochemical. That is, the energy will be very less. When you talk about the energy, all the amino acids, when you talk about the modeling, the mathematical modeling, the energy should be very, very less actually. The lesser amount of energy should be there. So then wherever there is a red, you can see that those amino acids are not corresponding to the energy level. That is not fulfilled the energy barrier. So these are the computational study. By simply looking the computational study, you will be able to tell whether the molecules are allied in a perfect stereochemistry, whether they are able to have the perfect secondary structure, whether they are having any clashes or steric clashes, steric hindrance, etc., etc. Then this is the another important tool called PROSA. In the case of PROSA, you know that this particular when you look at the Z score, there is a comparison between all experimentally solved structure Z score and the theoretical model. There is a dot. For example, the dot is minus 7.1 is the Z score. That means to say this dot is lying within this particular region. This is the probable region in which the Z score of all the experimental structure in the case of NMR. And similarly, this lighter region is the Z score of all the residue that comes under X-ray. So that is the way the Z score will be predicting. So Z score will be helpful. By looking the Z score, you can compare whether the structure of your own structure as well as the experimental structure that is already available will be having the agreement or not. Then finally, the structure need to be energy minimized. The total energy you need to calculate. That will be the stretching energy, bending energy, torsion energy, the weak interaction energy. All those energy should be important. That should be calculated. Then finally, you need to minimize the energy by using the advanced mathematical methods like Newton-Raphson method or steepest descent method or conjugate gradient method. So these are some of the important minimization approaches in computational biology, where you can use high-end softwares, to minimize the energy and to make sure that the molecules are in a perfect agreement, the residues are in perfect agreement. Then when you look about the structure-based drug discovery, there are 6 main important steps. Okay, this is this is what I have initially told. The prediction of the drug likeness, any drug molecule. Till now I have been talking about the target. Now we can talk about the drug. Any drug molecule, if you want, that should fulfill certain drug-like features. So that kind of whether this molecule are able to predict whether the molecules are able to fulfill the drug-like feature can be simply predicted by using bioinformatics. Okay, so that is the prediction of drug likeness, the prediction of ADME, then the prediction of toxicity. So all those things you can do bioinformatics. So those molecules from a pool of data, you need to check the drug likeness, then filter it, remove the molecule that is not qualifying the drug likeness, then you subject it to the adsorption, distribution, metabolism, and excretion, or such kind of pharmacokinetic studies, then select the molecule that fulfilling all those studies, then later you subject it to the toxicity, all the experimental animal. There are wonderful statistical models are available that models you can predict the toxicity, and finally those molecules are qualifying the the drug likeness or all of the, or reverse way you can do the molecular docking studies. So once you are getting the molecular docking, the interaction modeling, when you look at the interaction modeling, then those particular molecules are perfect. Interaction is very, very good with the minimum binding energy, the number of hydrogen bonding with the very less inhibition, very good inhibition constant, and all those things if you are getting, then you validate that particular things by molecular dynamic simulation. Where you create a virtual environment. Okay, in the that when you talk about the molecular docking studies, you are doing only dry lab. So when you're looking in the reality, the in vitro system, the solvent will be having an important impact actually. Okay, so whether you will be able to do that particular thing, solvent based system with the pH, temperature, all those things, you should do the molecular dynamic simulation in a computer based environment where you will create exactly like an in vitro system, energy binding of the interaction. Finally, the best result you can take it into and go for the experimental validation. That is the way how time and the effect, the time and the cost will be reduced actually. So these are the various databases where you will be able to get these small molecules. Okay, so for example, you are having NCBI PubChem. That is a wonderful small molecule database. Similarly, you will be having the drug bank. Okay, you'll be having the ChemSpider. Okay, ChemSpider database. Then you'll be having the Kyoto Encyclopedia of Genes and Genome. This is also another drug database. Then the Sync database. This is a molecule of this is a database of natural molecule database. Then ChemBMBL. Similarly, Supernatural 2. Then similarly, small molecule pathway database where you'll be able to get the molecule pathway. Then a NPAS. Okay, all those kind of databases you will be able to. You can able to explore and you can select the molecule whatever you want. Okay, so that is what it is easy. Then finally, you check the drug likeness. Computationally, you can check the drug likeness. Like Lipinski rule of 5 you can use. There are filters like CMC like rule, lead like rule, MDDR like rule, Berle drug index rule, Gauss filter, Egan filter, all those things you can do. These are by checking whether the molecule can be called as a drug or not. Similarly, you'll be having the pharmacokinetic studies, absorption, distribution, and toxicity. You'll be having statistical models, exactly how it is working in the in vitro system, the human intestinal absorption, in vitro CA to cell permeability, the MDCK cell permeability, skin permeability, or blood-brain barrier penetration. All those things can be studied by using the by using computational biology. Those molecule qualified all those filters, you can take it into further level and do the further analysis. There's a tool. There are a lot of tools like Schrodinger, Drug-Light2, Swiss ADME, Lead-IT, Fluxus, Pre-Admit, or so many tools you can check actually. Then when you talk about the fundamental rule is Lipinski rule of 5. So this is developed by Christopher Lipinski. So any molecule that can be called as a drug only if the partition coefficient should be less than 5, the molecular weight is less than 500 Dalton, there should be 500 hydrogen bonded donor, there should not be more than 5, and there should not be 10 hydrogen bond acceptor, and the rotatable bond preferably should be 15. This kind of rule is known as the Lipinski rule of 5. Then when you check any molecule, that particular molecule can be called as a drug. It should fulfill certain specific type of structural moieties. Okay, so the specific type of structural ensemble that is required for a molecule to call it as a drug is known as pharmacophore. So this pharmacophore, the contribution of a
Dr. Sinosh, please conclude in short now. Okay.
Okay, sir. Yeah, okay, sir. Yeah.
Yes, try to conclude as early as possible, please.
Yeah, sure. Yeah. So then these are the important aspects, and this is the the drug-like features, and finally you will be having the docking. You can do the docking. Finally, what I wanted to tell you, sir, you will be able to get the binding pocket. Okay, you will be able to assess the binding pocket, and you will be able to able to find out how accurately these particular molecules will be going. So this is what I have already told actually. So there are, so many bioinformatics tools and softwares then there are a lot of bioinformatics tools and softwares. So you can use all those softwares and tools, and you will be able to get this particular studies actually. And finally, you can use energy calculations, and you will be able to get such kind of things actually. So this is some of the by using bioinformatics, the anti-malarial properties of the one case study I will be discussing. Then I will be stopping this particular session, as respected Professor Deshmukh said. So the anti-malarial properties and the molecular docking analysis of compounds from these particular things as a novel anti-malarial agent. So they have the authors have here, it is they have looked at the lactate dehydrogenase enzymes, and they have modeled the structure, and they have identified a lot of molecules. Then they have done the interaction modeling, and they identified that this particular interaction, the modeling is a wonderful, they have a good binding properties and binding potential. So that is what I wanted to tell. Similarly, there are many. There are one studies from DS in molecular biosciences, the similar studies they have conducted, and synthetic molecules also they have looked, identified the interaction model. Another molecule they have used the computational biology, another paper, Pierre J. They have used the computational models, and they have validated by experimentally. So that is why I told you all the studies are, there are a lot of studies you will be able to find by bioinformatics method. So, to study this particular thing. So I would like to conclude my talk. So today is World Malarial Day, and computer-aided drug discovery is a very novel areas, and there are a lot of potential lead molecule can be developed, and bioinformatics tool will be helping to do this particular aspect. There will be molecule like anti-malarial drug with ideal drug-like pharmacokinetic features, so toxicity can be studied, the binding potential can be studied exactly, and finally it will go to the experimental level. So I am not telling that the computational biology is everything should be experimentally validated, but computational biology will be giving a significant output. So finally, I would like to express my deep and sense of thanks from my bottom heart to Professor Dr. Aravind Madhavrao Deshmukh and the National President of MSI. I am extremely happy that Sir is attending this meeting, and Sir is the person, he suggested my name to the organizer. Thank you, Sir. Thank you very much for giving me an opportunity for this particular delivering this particular talk. So I would like to thank Dr. Ajay K. Srivastava, the President of MSI Jharkhand unit, for inviting me and for your kind support. And I especially I thank Ria Gupta. She's the one, she kept constantly contacting me with the organizing secretary of the MSI student unit, and I am happy that such a kind of an extraordinary leaders are coming and making our MSI into greater heights. So that I'm happy that, thank you Ria for inviting me, and I also thank Sharanya Karmakar, the secretary of MSI unit. And what we wanted to tell you, sir, when you look at this particular malarial day, everything should start with me. There should be zero malaria, and my role should be significant, and I should be in a position to contribute a significant role to the society through Microbiological Society of India. So thank you very much. Thank you once again. Thank you very much.
Thank you, sir, for such a great presentation.
Evening to once again. Now I would like to call our chairperson and judge, Dr. Uma S. Singh, to announce the winners of Rangoli competition, which was held on 22nd April 2022 on the occasion of World Earth Day on the theme Protect Life on Earth. So kindly announce the winners. The mic is all to you, sir.
Oh, thank you. Thanks a lot for having given me a chance to announce the winners. Thank you. Those if I understand, there are 6 positions. First position, second, third, fourth, fifth, 6 positions. The results are they have been divided into 6 groups as well, and each group has 2 winners. So those who have won the first prize, those who have won the 6th prize, I must say congratulations. But those who couldn't be able to make it, I also tell them to, because failure is the pillar of success, and they must keep on trying. They will get one. They will be on the top of the ladder. Thank you. So the first prize goes to group 18, and the winners are Diksha Kumari and Shamila Baraik. The second position goes to group 20, and the names are Survi Kumari and Swishti Tadil. Third position goes to Group 7, Pallavi Kumari and Cecily Sriya. The fourth position goes to Group 8, Surbhi Gari and Anulekha Aditi. The fifth position goes to Group 21 and Sonali Dung and Srishti Cinco. Sixth position goes to Group 13, Akanksha Mehto and Anamika Mehto. Congratulations to the winners. And again, I would like to, on behalf of the group, I would like to congratulate them to the core of my heart. And great, thanks. Great going.
Thank you, sir.
Thank you so much, sir. Now I would request you for your kind reviews.
Oh, probably it is one of the toughest job I've ever got, because I've been hearing to a galaxy of scholars. The scholars, they are the masters of their own field. I'm not able to review anything, but I would say them that they have done extremely well and they have presented extremely well to what was the subject given to them. Dr. Swaranjit Singh, Dr. Dheeraj Nanda, Dr. Manish Kumar and Dr. Sinos. They all explained extremely well before the audience, and probably I don't mind, I will like to confess that some of the things went over my head. I couldn't be able to understand what the things were onto it. But really, they are the master of their own field. India is also one of the countries which is probably, if I recall correctly, while I was in one of the seminars, it was said that 95% population falls under the malarial region. And if the things go as per as the things are going as on today, and if the climate change goes on, probably this is going to cover 100% area going to come under malarial regions. So that's the reason that's one of the reasons why malaria has also become very important. The government of India says that we are going to eradicate malaria by 2030. I don't know, I have my own doubts, because if I recall correctly, when I was in government of India looking after finance, and the eradication program, there are many papers on it also. The eradication program requires 5 to 6 billion of rupees per annum. And if the things go well, and if my memory serves me well, the expenditure is somewhere around 1.94 billion per annum. So there is a gap of somewhere around 4 billion of our currency. And if we look at it, probably the things are yet to go to the level we desire or we aspire for. India reports somewhere around 2 million cases per annum, and the caseload is very heavy, and it reports 1,000 deaths per annum. This is also one of the area which really concerns us. And most of the malaria infested areas are the forest dominated areas, and those living in the forest are naturally one who are not been able to get the medical support, because medical infrastructure in our country is pretty bad. Let us concede, let us confess, and because I have seen, having worked in the field area, most of the PSCs, either they don't have any doctor, they don't have any manpower to name, and I don't know how they are just being treated. That's one thing to be looked at. There's some other areas which Dr. Sinos mentioned, and I also agree with him, that the drug resistance, then insecticide resistance, lack of knowledge about the diseases are the areas of our concern. So they have to be taken into consideration before we decide to eradicate malaria over our country in 2030. Let us see what happens. But I would like to thank all of you to be very, very we are really grateful that you have given us a very wonderful presentation, a lecture, and trust me, I have learnt a lot. And I'm going to read more on these areas, more on these issues, because malaria was never my issue of concern. So I'm just going to read and to be able to understand what it is like. I'm thankful to everyone, like Ajay ji and Dr. Deshmukh.
Challenges in the eradication of malaria. Many challenges are there, but I hope soon it will be thankful first.
So again, thankful to Dr. Ajay ji and Dr. Deshmukh for having given me an opportunity to be with you. Thank you. Thanks a lot.
Thank you so much, sir. Now I would like to request our chief guest, Dr. Swaranjit Singh, sir, to give a review on our webinar.
Okay. Thank you very much. Thank you for the opportunity to address the esteemed audience. It was a very well-organized webinar. The three resource persons did a wonderful, excellent job in presenting the latest advancements in malaria control. Let us hope that very soon malaria will be eradicated from our planet and become a thing of the past. I congratulate the MSI, especially Dr. Deshmukh, and the management of St. Xavier's College, Ranchi, for getting us all together for a noble cause. Thank you very much. Thank you very much.
Sir. Thank you, sir. I am privileged to invite Dr. A.M. Deshmukh, sir, President of Microbiologist Society India, to say some words about the webinar.
Thank you. Thank you very much. Today, I'm really happy to see that Riya Gupta, Charnia, and all students are conducting such a wonderful seminar successfully, and to bring the students on the platform, credit goes to, of course, Dr. Ajay. So today's seminar was a really wonderful seminar, and the speaker, including Dr. Sinosh, then Dr. Sinosh is from UP. You see the beauty of today's seminar. Dr. Sinosh is from Kerala. Dr. Manish Kumar is from Madhya Pradesh. Dr. Dheeraj Nanda is from Orissa. Dr. Swarna Singh is from Chandigarh. Dr. Uma is from UP. Dr. Ajay is from Jharkhand. And Dr. A.M. Deshmukh is from Maharashtra. It's a really combination of all states made today. And today's lectures were on different aspects of malaria. Very knowledgeable lectures. They have tried. Actually, the time is not. And I hope that in the future, student team will again arrange a seminar on the different topics like a malaria. There are many other topics in India having burning issue. Example, just Dr. Sinosh has told. That is antibiotic resistance. Multi-drug resistance is becoming now total drug resistance. That is a severe problem India is facing. So you can arrange a seminar on this topic or many other topics are there. As a president of Microbiology Society, I am always with you. I should appreciate your efforts. And I should thanks Dr. Swaranjit Singh, Dr. Uma, apart from the speaker, they have contributed, they have given their reviews, and they have given well wishes to such seminar. Thank you students again. I will not take the name of specific student, it is a teamwork. And thank you Dr. Ajay for supporting the student team and making them.
Thank you, sir.
Thank you very much. Thank you.
Now I would like to introduce to our co-patron Dr. Ajay Kumar Srivastav, President of MSI Jharkhand Unit. He was the head of Department of Botany at St. Xavier's College, Ranchi. I'd like to ask to give a review on this webinar, sir. The mic is all to you.
But it's largely because of the three majestic lectures focused on the topic malaria, the issue of malaria, and the chief guest and the chairperson, they connected the pieces wonderfully well. So, but the highlight of the webinar is that the organization